Okay, good day, guys. This is Mr. Stolle. So today we are looking at 2016 November, grade 11, paper 2, Maths grade 11, paper 2. Now it reads, in the diagram below, negative P, negative 8t is a point on the Cartesian plane such that OP is equal to 17 units and reflex XOP is equal to theta. Now your reflex is above 180. Now they're asking us calculate the value of T. But also another thing here that you need to note here, that when we are given this diagram here, you must know, remembering from the past lectures, we know that this whole theta here is equal to this angle here that we have here. Is equal to this angle, and this angle here will be acute. So how do we get this angle? We say whatever angle is there, theta minus 180 to get the acute angle. Okay, so you must not forget about that. Now, so we are told that 8 and negative 8, and negative 8 is in terms of x. So we are saying it's actually negative 8 this side, and your t is your y. So your t is actually a y. It shows you the y value. So that's what we have there. And here we'll be having a 90 there. Now they want us to calculate the value of t. Now, value of t, how do you get the value of t? You are using Pythagoras theorem. So you must always remember that when you're dealing with trigonometry, there are things that you need to remember. Pythagoras theorem, the sine rule, the cosine rule, you will see where you use it, and also how to apply a cosine in terms of the size of the right angle triangle. Like we say, sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse. You must always remember these things so that it actually assists you in answering questions. So you have to link a lot of things. Now, calculate the value of t. Now, t, we see that t is actually the opposite side. So we are saying this is our theta again. So it's actually the opposite side. So we know that we are given the opposite. What are we given? We want to find the opposite side, but we are given the hypotenuse. So what do we do now? First of all, we know that we're going to say 17 squared. So we know that through Pythagoras theorem, h squared is equals to opposite squared plus adjacent squared. That's what we know. And here we are actually looking for the opposite squared. Opposite side is going to be equals to hypotenuse squared minus adjacent squared, which is going to be equal to 17 squared minus negative 8 squared. That's what we have there. Then what do we get? 17 squared minus 8 squared. We get 225. Now, O is going to be equals to root of 225. Now, to remove the power of 2, we actually root both sides. So we are saying root answer. What do we get? We get 15. So now remember, from a root, we get plus minus. Always remember that when we root anything, we get plus minus value. So it's not a positive, plus minus value. But now in our scenario here, you check which one would you consider as t. T will be negative because you know that y is negative down here. So you're going to choose t is going to be, negative 15 units. Okay. That's what we have there. Okay. Then let's check the next question. Next question, it reads, determine the value of each of the following without using the calculator. Without using a calculator. Now, everything is given to us now. Like I said here, this is more like your theta, okay, the smaller angle there, because now we say theta minus 180. But now let's check here. This is the opposite side. This is our now negative 15. So it's negative 15 here, and it's negative 8. Then now what we are asked to find cos negative theta. Cos negative theta. Now, cos is equals to cos theta, cos negative theta. If you check our reduction formula, reduction formulas on Trig 2 lesson, you can check on our page, then you find that we have done this. Cos negative theta is equals to cos theta. And what is our cos theta? Cos theta is equals to adjacent over hypotenuse. So adjacent over hypotenuse, which is going to be equals to negative 8 over hypotenuse is 17. So your cos theta there will be, will be negative 8 over 13. Okay, 511. Okay, now let's move on to the next one. B, this is A. Let's move to B. B is saying 1 minus sine theta. 1 minus sine theta. Now, what is our sine theta in this case? Sine theta is equals to opposite over hypotenuse. Opposite over hypotenuse, which is equals to negative 15. So it's negative 15 here. I don't know why I made a mistake here. Negative 15 over 17. Okay. And this negative also indicates to you that your sine and cos are negative in the third quadrant. Only tan is negative, is positive in the third quadrant. So we are going to substitute that. It's going to be 1 minus, we put it in bracket, negative 15 over 17. Then what do we get there? We punch it in our calculator here. 1 minus, open the bracket, minus 15 over 17. We get 32 over 17. So this is our final answer. This is our final answer here. Now let's move on to the next question. Is saying if sine 17, sorry, so this 5.2, if sine 17 is equals to A. But listen here, guys, when you are given any value, like any letter in this case, you are given A or B or X or I don't know, you have to say it is over 1. It is over 1. And you knowing your triangle, you are going to use a triangle to answer this. You are going to use a triangle. When they tell you that no using of calculator, you must always remember that you must have a triangle. You create your triangle here, and your triangle is going to help you because your triangle is going to have your opposite side and everything. So what you're going to do here, you're going to have 17. I'm going to put 17 here. Then we have got 90 here. And what we have, this is our angle. Okay. And opposite to that, we have got A. What is our hypotenuse? Is equals to 1. That's what we are given there. That's what you have to deduce there. Now, from there now, we need to calculate the side that is not given to us. The side that is not given to us. So you need to complete the triangle first. You need to complete the triangle first. Now we know that here let's call this just maybe, let's say it's X. So you're going to say X squared is going to be equals to 1 minus 1 squared minus A squared. X is going to be equals to root of 1 minus A squared. So in this case here, this side is 1 root of 1 minus A squared. Now everything is going to be very easy now from there, because now you have got all your sides of the rectangle, triangle, whatever comes you can actually tackle. Now let's see here 5.21. It's saying tan 17. What is our tan? Tan 17, we know that tan 17 is equals to opposite over adjacent. What is our opposite? It's A. What is our what is it? Adjacent? It's adjacent to the angle of is 1 minus A squared. Now 1 minus A squared, you must remember that you mustn't have a root at the what as the denominator. But in this case here, you can leave it, it's fine. You can even leave it like this, there's no problem. But I will show you, you must rationalize. But in this case, I don't think you have a problem. You can actually leave it like this. This is your answer. Now let's move on to sine 107. Sine 107, 5.22, sine 107. Now you have to worry now, how did they get 107? Now, before I continue, we need to also to fill in this angle here is, we get it by saying 90 minus 17. And what is it? is equals to 90 minus 17, we get 73. 73. Let's fill it. Now, here, how did they get 107? How do we get 107? How is it related to the 17 and or 73? We are going to say now, maybe let's try to check 107, 180 minus 107. What do we get? We get 73. Can you see that? So sine 107 in sine is positive is equal to sine 73. And sine 73, how do we get we say opposite over adjacent, opposite over hypotenuse, over hypotenuse, which is going to be equals to opposite, it's root 1 minus a squared over 1. So which is going to be root of 1 minus a squared. That's it. So that's sine, what is it? 107 or sine 73. Okay. Let's move on. Let's move on to another question. 5.23 is now saying 5. I hope it's clear. 5.23 is now telling us that cos squared 253 plus sine squared 557. Now, remember from our triangle, I just wanted to explain to you. I'm doing this so that you understand much better. This is our Cartesian plane, and we know that this is our, this is 0. We started from 0 there. We move anti-clockwise. We have 90. Then we've got 180. We have got 270. You have got 360. Now 360 plus 90. 360 plus 90. We get 450. Then 450 plus 90. Plus 90. We get 540. So in other words, here we have got 540. Then down here plus 90, we get 630. Then down here we get plus 90, we get 720. 720. So this is how it goes. It goes on like this. We continue to add 90. So you can see now which quadrant are we talking about? Which quadrant does your value lie? So let's talk of cos 53. Cos 253. Cos 253, where does it lie? It lies after 180. And where is it? Is in the third quadrant. In the third quadrant, cos is 90. Its cos is what? Cos is negative. But how do we get the acute angle now? How do we get acute angle which is equal to 253? We are going to say 253 minus 180. We get 73. Can you see this? We get 73. So now it actually means that your cos 253 is equals to what? Squared, is equals to negative cos 73, like this, squared. Because the cos squared is just the same as we are squaring everything, okay? That's what we are having there. What about sine 557? Sine 557, how do we get that 557? 557, we see also that it's actually in the third quadrant. It's in the third quadrant. How do we get the acute angle? We're going to say 553 minus 540. We get, is it 553? 557, 557. We get 17. So we're actually saying sine squared 557 is equals to, it's also negative here, negative cosine 17. Now, here you have everything that we need. You have everything that you need we refer back again to our triangle that we're having, because they're saying don't use a calculator. So you must always try to find the acute angle that is equal to what call your, whichever is going to be obtuse or it's going to be a reflex angle. You don't need to stress, but just try to find out which quadrant does your angle lie. How do I get the acute angle from there? Then that's it. Now from there, now what are we going to do now? We're going to say we know the value of what? Cos 73. Cos is equals adjacent of hypotenuse. So in this case here is negative a squared plus, then what do we have? So here what are we going to have here? Sine 17, negative sine 17. Sine 17, we know that is opposite over hypotenuse. Opposite over hypotenuse, which is going to be plus a squared. What do we get? We get a squared plus a squared. What do we get? We get 2a squared. So this becomes your answer like that. Okay, that's how you get your answer there. Okay, so I hope you guys understand this. I hope you guys understand this. Always remember, just draw even a side in, just draw on the other side. Just try to draw your sketch, your what is it, your Cartesian plane. It doesn't take you time if you know your stuff, because remember it oscillates, it just comes back. Remember your graphs they comes, you understand? So it's repeating same points, coming back to same point. That's why we are saying it continues to go right around like that. Now let's move on to the next question here without wasting much of your time. This is 5.3. Let's check 5.3. 5.3. They are saying now simplify without using a calculator. Once they say without using calculator, without using calculator, then you know that you are using special angles. You are using special angles. Without using a calculator, think of special angles. What are your special angles? These are acute angles. And how do you get acute angle in the second quadrant? In this case, you say 180 minus theta, which is the acute angle, if you've got theta there. Then in the third quadrant, how do you get it? You say 270 minus, whatever angle that we have, sorry, 180 minus theta. Then to get whatever angle that we have here, let's say it's what is it? It's 180 plus theta. 180 plus theta. Then what about the other angle here? Is 360 minus theta. That's how we do that. So if you are to be given any angle above 180, you are going to say whatever angle, let's say it's 250, you're going to say 250 minus 180 to get your theta, the acute angle. Okay, that's what you need to know here. But let's come to our question. It's saying, it's giving us cos negative 225 sine 135 plus sine 330 over tan 225. Now, when we are given this, we know that we want to find the acute angle to what called your 225. What is it? It's in the third quadrant. You are going to say 225 minus 180. We get 45. So this is going to be cos negative 45, because the negative shows you that your graph is, the angle is there on the negative side of the your what Cartesian plane there. That's what it means. So it's cos negative 45. Then 135. How would you get the angle in the acute angle? You say 180 minus 135. You get 45. So it's gonna be sine 45. Then from there, what is sine 330? Sine 330, you say cos, say 360, it's in the 34th quadrant. You say 360 minus the angle that you're given, which is 330. What do we get? We get 30. So it's going to be times sine 30. Then we underline that. Then what are we given there? Tan 225. We know that 225 is the same as 45. So it's going to be tan 45. Now, when they say without using a calculator, they want you to show all your working. They want you to show all the steps. That's what they mean. They want you to show all the steps. They want you also to use your acute angle, the acute special angles. That's what they want. So when you represent this, you get all your marks by just writing this. Now, let's moving on to finding the values now. You know that cos negative 45. Now, remember, when we say don't use a calculator, you can't remember these values. So you just punch here. If you have to punch here, cos negative 45. It doesn't give you a decimal. It doesn't give you a decimal. So you get, not cos negative 45, sorry. This should be negative because it isn't negative. So the negative, remember, continues to be, what is it? Continues to be the negative of the what? Of the, what is it? The quadrant, the angle, side of the angle. So it's actually negative here that you must put here. So we are going to say cos 45 is root 2 over 2. Cos 45 is root 2 over 2. So we're going to say negative root 2 over 2. We put in brackets, remember. Then cos 45 and sin 45, they are equal. So root 2 over 2. Then what do we have? Sin 30. Sin 30 should be half there. Sin 30. Sin 330 is supposed to be negative, sorry. Negative sin 30 because it's negative in the fourth quadrant. It's going to be negative 1 over 2. I forgot to write that. I forgot to indicate that. Please don't forget here. Then what do we have here? We put our sin tan 45 is 1. Tan 45 is 1. Then we have our 1 there. 1. So this is what we have here. So you see where you get your marks. You get your marks by writing the acute angle, acute special angles, acute special angles. That's where you get your marks, and you get your marks again by also writing the values of those acute angles, the special angles. Then from there, because if you just punch everything here, you're gonna get to the answer. But you need to show that you know that 135 is equivalent to 45, and 45 we know is actually value. Now, then this one you're just punching in your calculator. You can just punch in your calculator. You don't need to stress. Let me put it our calculator this side here and punch it in your calculator. Remember, here you put your brackets. You punch it as it is. Root 2 over 2. Okay. Root. So it's gonna be root 2 over 2. Then you put again another bracket, negative 1 over 2. So over 1 is just 1. You don't need to stress about that. Then what are we getting? We are getting of 1 over 4. 1 over 4. That's our answer there. 1 over 4. That's our answer. Is it correct here? Let me check. Negative, we are multiplying 1 over 4. Right. I made a mistake here. This should be negative. There shouldn't be a bracket here. Let me just try to find the rubber here. Because here we are having a positive here, and we mustn't have this bracket here separating. My apologies for that. Okay, so I've just rectified that. Now, so you must also see that we also make mistakes. Everyone make mistakes, and you must try to check always your work, that are you following up with whatever you wrote on top there. Okay, so these are such mistakes that actually happens when you are in a hurry in the exam, and you think that you did well, and no, you actually made some mistakes there. So you can see that we are supposed to get -1 in this case. We're supposed to get -1 as our final answer. Okay, that's what we have there. Okay, let's move on to the next question. Now, the next question requires you, wants you to prove identity, proving identity. Proving identities, we are told that it's prove that, let's see here, we're gonna have that. So we want to prove that 1 over cos x plus 1, okay? Okay, now you see in bracket cos x minus 1. This one is going to be minus 1 tan squared x times cos squared x. Okay, that's what we have there. And now they want you to prove the identity that this is equal to this. Now, identities you can use either way. You can prove from left to right, or you can prove from what go right left. Either way, as long as you just see which one is easy for you to show that it's what called the identical. So we're gonna start. We can start with this idea. Now, by looking at this, we say 1 over. So let's right left hand side. That's what we are going to prove. Okay, let's start with that. Now here, when you are given this, you know that this cos x plus 1, cos x minus 1 is difference of 2 squares. It's difference of 2 squares. So you are going to say have 1 over cos squared minus cos squared x minus 1. Difference of 2 squares, cos squared x minus 1. That's what we're going to have there. Then from there, we see that cos squared x minus 1, it gives us from the identity that says sine squared x plus cos squared x is equals to 1. We know that here, when we say cos squared x minus 1 is going to give us negative sine x. So if you make cos squared x minus 1 here, we're going to get negative sine x. So it's going to be negative sine squared x. That's what we mean here. So now, when you've got negative sine x, sine squared x, now we take it from there, we see what are we going to do now when we've got negative, what is it? Negative 1 over negative sine x, 1 over negative sine x. Now we come back again and say, you use what you call modification. You are modifying. When you are modifying, you are putting something that is going to be equal to 1. So 1 doesn't change anything. So here in this case here, you are going to, because you want to go there, you want to get to what you call 1 over tan, what is it? Tan squared plus what you call tan squared times cos squared x. So you just have to check here and say, all right, what should I do here to have tan is equal to tan. We know that tan squared x is equals to sine squared x over cos squared x. That's what we know. That's the identity here. So we know you just need to come up with a plan of now. What should I do? What should I modify? How should I modify my equation? It's gonna be 1 over sine squared x over cos squared x. Now this one times what? Cos squared x over 1. So here is the same. You just put cos squared. You have modified with what you call cos squared x over cos squared x. That's what we just did here. That's what we just bring in here. When you bring this one is just equal to what? To 1. So you're not changing much. You're not changing anything. But this will give you the answer that you want. Now here, what are we going to have? We're going to have negative. Now the negative 1 is on top there, and what are we left with? With sine squared over x, cos squared x is equals to tan. So we are having tan squared x, then times what? Times cos squared x. Then what have we done now? We have proved the question. You have proved what they wanted us to prove. Then let's move. Let's see here the other one here. How we're going to do it. Now the next one is asking us to prove. No, we can try it from the left hand side. Let's try from left hand side. right-hand side, sorry. Right-hand side is what? Is equals to, you have got your negative 1 over. Now we've got negative 1 over tan squared x. So whenever you're given this, you must expand it. You must expand it. So when you're given tan, always for proving identities, expand it, please. Then what are we going to do? You're going to have sine squared x over cos squared x times, you are already given cos squared x over 1. Then these ones here will cancel. Now, when it cancels, what are we left with? We are left with negative 1 over sine squared x. And what is sine squared x? The negative sine squared x, negative here. Your negative now, you're applying it on the sign now. You're applying it on the sign. Now, when you apply it on the sign, you come back here to say negative sine squared x goes to cos squared x minus 1. Cos squared x minus 1. Or maybe you can, if you can't do that, you can say sine squared x is going to be negative 1 over cos 1 minus cos squared x. 1 minus cos squared x. When you've got 1 minus cos squared x, when you multiply with the negative here, to remove the negative, you are going to have 1 over cos squared x minus 1. And this is difference of 2 squares. What do we have? Cos x, sorry, plus 1 cos x minus 1. That's what we have here. Difference of 2 squares. A squared minus b squared is equals to a plus b, a minus b. That's what you need to know. If both of them can be squared, like here, 1 squared is just equals to 1. Cos squared minus 1 squared is equals to cos x plus what is it, plus 1 cos x minus 1. Okay. Now let's check our last question. Our last question is saying, determine the general solution of 5.5 of 2 sine x cos x is equals to cos x. Now, you can be tempted to say, let me just cancel cos. But please, here, you must bring your cos this side. You have got 2 sine x cos x minus cos x is equals to 0. Is equal to 0. So this is more like factorization. When you're factorizing. Now here, what are we having? You are factorizing. Now you're going to say, what is common here is cos. So you're going to have cos. You're going to take out cos x in bracket, you're left with 2 sine x minus 1 is equals to 0. Now, when you're given when you're here now, you know that either cos x is equals to 0 or 2 sine x minus 1 is equals to 0. So you're going to say cos x is equal to 0. Now, when you're given cos x is equal to 0, you know that you are going to say, for you to get 0 here, what must you have now? You know that you're going to say arc cos of that. So x is going to be equals to arc cos of 0. Arc cos of 0. What do we get? Shift cos 0, we get 90. So we get 90. And when we get 90, listen here, we get 90 plus 3k 360. 90 plus k 360. But remember, what is our cos? When you are solving this, you must remember again, come back to your Cartesian plane again and see what is our cos. Cos is a positive here. So here is cos, this is all, they are positive. Sine here, tan here, and what? Cos here. So this is where it's positive. So you must also look out for the second angle. You must also look out for the second angle here, that where cos is positive. How do you get that the second angle? You say 360 minus the angle. I have emphasized that. So you say the second one, or 360 minus 90 plus k 360. So we put this in bracket. Now 360 minus 90, you're going to get 270. So you're going to be 270 plus k 360. That becomes your answers here. So, and now let's go back again. We are saying it can be cos, that is 0, or 2 sine x equal to 0, which is 2 sine x is equals to 1, and your sine x is equals to, what is it, 1 over 2. And when you have got 1 over 2 here, we know what we do here. X is equals to arc sine of that, 1 over 2, and arc sine of 1 over 2 is 30. So shift sine 1 over 2, we get 30. So again here, we're going to get 30 plus k 360. The period is 360. Now, or how do we get the angle in the second quadrant? Because sine is positive here, we say 180 minus theta. 180 minus 30 plus k 360. 180 minus 30, what do we get? We get 150. 180 minus 30, we get 150. It's going to be 150 degrees plus k 360. That's what we get. So these are the answers that you'll be expected to actually to show in your, what is it, in your answer sheet. Okay, this is the answer that you will be expected to show that that's what we get. So these are the answers that you should be expected. Okay, so I hope you guys, you have mastered here how you are supposed to answer, especially when you're dealing with what you call your cos. Remember your cos, where is it positive, where is it negative, your sign as well. And also when you're doing general solution, you give 2 answers. You give what? 2 answers, 2 answers and 2 answers. One is the acute angle from the first, first, and the other one is where that particular what you call variable is. It can be sine, can be cos. But also when you say, let's give an example here, you find that we are saying that sine, sine theta, sine x is equals to -1. Let's say you are given -1 here. When you're given -1, you know that negative sign is negative in the in the third and fourth quadrant. So you know that you're going to say arc sine of that, arc sine of, so x is going to be equals to what? We know that it's going to be equals to, is -30. Just say negative what? Arc sine of -1 over 2. Arc sine of -1 over 2 is going to give us -30. So, but now you can't write this -30. Okay, what must you do? You must find the angle in the third and fourth. So you know that here is going to be third and fourth. That's where your answer should lie. That's where your answer should lie. So that's where your answer should lie. And how do you get angle in the third quadrant? You say 180 plus that theta. So it's going to be 180 plus 30 plus k 360. And what is 180 plus 30? 180 plus 30, we say it's going to be 210. So it's going to be 210 plus k 360. Or we also say 360 minus 30 to find the angle in the fourth quadrant. Is going to be 360 minus 30 in bracket plus k 360. Then what do we get there? We're going to get 330 plus k 360. So this is not part of the question, but it's just for you so that you understand. So when you get a negative value here, what must you do? You must know that it lies in the third and fourth quadrant. Okay, so until next time, guys, thank you so much.